Assalamualaikum warahmatullahi wabarakatuh. We continue our session 1, part 3. In part 3, we will learn about Carnot cycle and its value in engineering. What is Carnot cycle actually? Well, at first, we have to know that the Carnot cycle is a theoretical thermodynamic cycle which proposed by Nicholas Leonard Sadi Carnot in 1824. So it provides the upper limit of on the efficiency that any classical thermodynamic cycle can achieve, which means that the highest efficiency that the cycle the cycle can achieve is only by using Carnot cycle. Okay, during the conversion of thermal energy into work or conversely. Actually, Carnot cycle is not an actual thermodynamic cycle, but a theoretical construct and cannot be built in practice. So meaning that the Carnot cycle is actually 100% theoretical cycle. And a system undergoing a Carnot cycle is called a Carnot cycle heat engine. So a Carnot cycle is composed by 4 totally reversible processes. Okay, but first of all, we have to introduce you what is the meaning of the isothermal isentropic process. So isothermal means that the in 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 the isothermal process, the temperature is remain the same. The temperature is remain the same. As we can see in the TS diagram here, that the process from 1 to 2, the temperature is same. T hash. Hash means high. TL, L means low. Low temperature, high temperature. So isothermal means that temperature is same from point 1 to point 2. And we call this process from 1 to 2 as isothermal. Same goes with the 3 to 4 isothermal because the temperature remain the same. Okay, now what is isentropic? Isentropic means that the entropy is remain the same. We take a look at the same figure, TS figure, as shown in my pointer. So, in this TS diagram, the process from 2 to 3, 4 to 1, the same value is the entropy, S is entropy. So, entropy at state 2 is same as entropy at state 3, while the entropy at state 4 is equal to the entropy at state 1. And therefore, we call this process 2 to 3 and 4 to 1 as isentropic. As isentropic. So now we already clear what is mean by isothermal and isentropic. But now, we know that the Carnot cycle is composed by 4 totally reversible processes. So we look into this picture, this figure. From 1 to 2 is isothermal process in turbine where the heat enter the cycle. So we call it as a isothermal heat addition. While in process 2 to 3 is isentropic expansion. isentropic expansion at turbine. And then it goes to 3 to 4, where isothermal process is happen again, but in compressor, where heat is rejected from the cycle. Heat is rejected from the cycle. And lastly, the process from 4 to 1 happened at the compressor, isentropic compression. Okay, when we interpolate, when we express this process to the diagram, we have two main diagram, which is PV and TS diagram. Uh, so that therefore, we can see the heat into the cycle is from 1 to 2, and heat rejection from 3 to 4. While the process clearly, the picture of the process is clearly can be seen in this TS diagram. So this is what we call as a Carnot cycle, and it's totally reversible, and it is do not occur in actual case. Carnot cycle was introduced as the most efficient heat engine. Why so efficient? Because it's totally reversible. Remember? That operates between two fixed temperature at high temperature and low temperature. The thermal efficiency of the Carnot cycle is given by this equation. So, how that they derive this equation is actually the thermal efficiency of the cycle in this chapter is actually how much work that we can produce by the cycle divided by the how much heat that we give to the cycle. So the how much work that the cycle can produce is of course it's come from the how much the heat that we give to the cycle minus how much heat that rejected from the cycle. So work net is actually Q in minus Q out. So we substitute this work net into Q in minus Q out, and then we simplify the equation, and then we know that Q out is actually the T hash times the difference between entropy 1 and entropy 2, while the Q out it is actually at low temperature times the difference of entropy at 0.3 and 0.4. But we know that the entropy at 0.2 and 0.3 is equal. Yeah, is equal. We can look at this diagram, TS diagram. So the entropy of 2 is equal to 3 and 4 is equal to 1, and therefore the Q out can be Q out, the term S2 and S4 can be replaced by S2 minus S1, and therefore we can cancel these terms and become 1 minus TL over T hash.